Welcome back to this lesson. So in this lesson today, we'll be looking at chapter 8 of our content of the book Multi-Agent System Pattern for Enterprise Scale System. So the book is on Amazon. Please use the link below to get your copy. It's a very wonderful book. And that is my first book as an agentic AI engineer with expertise in data engineer. And of course, I apply my mathematics principle as an, MSc and BSc mathematician to design the architecture with experience of data engineering and cloud computing, security and governance. So it's a very, very fantastic book. Get your copy and leave a review. Thank you. So in our guideline courses from the book, I'll be looking at the title Security and Governance for Enterprise Multi-Agent System, which is the content of chapter 8 of the book. So I look at security and governance for agent fleets, covering authorization, communication, privacy, access, and audit trail, including encryption of states, encryption of databases, and encryption of communication in transit and information at rest. So that is all I discuss in the content of chapter 8. So what is security and governance, and why is it important in agentic system design? So security and governance, multi-agent system are not just software components. They are more than software components. They are software components with more capability than ordinary applications or software. They are autonomous business, they are autonomous business personnels with authority. They have authority. They have action because they plan, they reason, and they act. Okay. And as a result of this, you should design identity. You should design for identity, access control, encryption of information at rest and in transit, audit trails for compliance and governance, threat modeling, vulnerability management, and governance into the system. It is very, very important, very, very important, very, very important that you implement these 7 layers of security and governance when you are designing multi-agent system. So security for this system requires designing security into the architecture. You can't do without designing the security. If not, you will have a compromised multi-agent system. You're going to have threat attack. You're going to have prompt injection. You're going to have even misuse or, agents accessing databases and communicating with, using information, PII information that they are not supposed to use. So it is very, very important that you design security in depth into the system architecture of multi-agent orchestration or pattern. So AI agents need identity because they can take action. Identity is very important because AI agents take action. They plan, they reason, they think, they work. So you should be able to trace, their action, their movements, their activity by assigning identity to them. Okay, so each agent should have service accounts. Can you see that? Each agent should have their own service account, just as you have service account for every cloud application that you're accessing. If you want, an application to use a storage account, you assign the service account storage account to the application. If you want an EC2 virtual machine to be able to write to a storage account, you assign a service account of the storage account to the EC2 virtual machine. So agents should also have what we call the service account or the OAuth2, scope permission, and short-lived credential, okay, that allow them to access and use tools, use APIs and databases. So use the JWT, OAuth2, mTLS for message in transit, communication in transit, and secure agent communication. So message signing protects against tampering and replay attacks. Sensitive data must be encrypted and PII must be redacted. So do not expose personally identifiable information to agents without redacting them. Make sure they are redacted before the information gets to the agent. Role-based access control and attribute-based access control control what each agent can access or do. Okay, implement role-based access control. Make sure you limit data usage to minimization and anonymization. Anonymize PII information and minimize data usage by implementing role-based access control and attribute-based access control. Immutable audit trails record agent action and decision. So audit trail record all the action and decision of agents for governance and compliance. Prompt injection, memory poisoning, and agent misuse are real security risks. So design to protect the agent against prompt injection, memory poisoning through, steal, information, and misuse of database information. Governance charters define agent authority, limit review rules and escalation patterns. So implement governance and defense in depth into the multi-agent system. So what are multi-agent system security and what should you make sure that you design into the security system? So first of all, multi-agent system security. Implement multi-agent system security, which is a category of risk enterprise technology leaders worry about too late. So do not make security an afterthought. Implement and design security into the system. Just as you implement and design observability and monitoring into the system, and you design memory state, you design communication, you design state management, you design orchestration and the agent themselves, you design for scalability and performance. Security should not be an afterthought. Security should also be designed into the infrastructure. Do not make it, do not design security after you have designed the whole system. Design security as part of the system from the beginning when you are putting your architecture together. Real business authority. Orchestrator dispatch task to specialized agents that create purchase order. So make sure you assign business authority into the system. Also implement interaction surface. That's a network of 15 agents sharing state through 3 storage tiers. So make sure you design for interaction, a platform where the agent can interact, and make sure the interaction is also secure through mTLS. External threats. Adversarial actor may inject prompts, extract sensitive data, and poison data in the system. So make sure you defend against external threats. Supply chain threats. Of course, there's also what we call supply chain threats in supply chain agentic system, which are compromised dependency, malicious packages, CI/CD pipeline attack. Also designed against this. Internal threats. Even what is in the system cannot be trusted. So what we are saying here is that you should not just implement perimeter security. Make sure you, also, do not trust what is in the system. Okay, I know we do not trust what is outside the system. So also do not trust what is inside the system. Implement zero trust. Very, very important. So internal threat, agent can drift from objective. They can generate, poor output, can reduce quality. They can hallucinate. They can raise on share state. They can get misconfigured, and they can misuse permission. So do not trust the agents themselves. They are not to be trusted because they are built on LLM, and you may be using third-party LLM, you may be using Claude, okay, and Claude may be giving you haiku, Claude sonnet, or opus. So you don't know what a opus may be causing your multi-agent system to do. So do not trust the agent themselves. Implement zero trust. Okay. Design security into the agentic system. Make sure your prompts are secured. Make sure the agent implements role-based access control and attribute-based access control. Make sure you redact PII information. Make sure you limit what tool they can call, what API they can access, and so on and so forth. So the first design pattern we look at is authentication. How do you design authentication into multi-agent system design? So multi-agent system, in multi-agent system, every agent needs a unique traceable identity, as we have said before. Identity is the first thing that you must design into the agent. Every agent must have identity. Okay, so if this is agent A, identify it as agent A, this agent B as agent B, agent C as agent C. So just like human being in every department, every organization have a name. You identify human being by their name, by their line manager, by their function, by what they do. So also make sure you assign name to every agent. Give them identity, just like you have identity card for workers. Give your agent identity. So agent identity are permanent identity for agent service, just like a service account for cloud application. Like if you want storage, if you want an application to have access to storage account, you give a service account of the storage account and assign it to the application or to the virtual machine. That's how it works here. So permanent identity for agent service is just like their service account. So each type has a service account. Instance have unique certificate. Capability scope, declarative definition of agent authorization, runtime enforcement, ensure least privileged access. So make sure you define the capability scope of the agent. Do not give agents 100% capability. Scope the agent to what you want them to do. Okay. So if you are building a data engineering agent, and do not design one agent to extract, transform, and load data, analyze and visualize. No, make sure you design an agent that will go into the database and extract the data from wherever it is from. Design another agent to transform, design another agent to load, and design another agent to implement KPI information and analyze your data and generate a table for visualization. And then you can design another agent that will visualize the data, and you design another agent or a RAG database agent that will go into your historical data, generate information to augment whatever the KPI agent generates, and then visualization agent combine both information and visualize the agent. So that is how workflow goes. So limit capability to scope level, scope the capability, and then limit what the agent can do, what they are capable of performing. Do not just give them a 100% scope. So this also enable you to trace log, track the agent capability, the agent communication, whether they have gone beyond the policy and the compliance rule that you define for them. We have agent credential, short-lived credential for current task. So this is defined through, using OAuth 2. Scope strictly to specific requirement. Make sure you scope credential authorization to specific requirements. So if an agent requires read access to database, give only read access. Do not give write access. Do not give delete access. Do not give contributor access to an agent that only read access. If an agent needs write access, that is, in data engineering, you have, an agent that will load add data into the database. So that is a write access. So do not give the agent another access other than that. Do not give it delete access or whatever access that is beyond that. So scope, access to a particular task that you have defined for the agent. Agent ID provider. root of trust for the fleet, issues and validate credential, integrating with KPI and secret managers. So ID, make sure you have identity provider. If you are building on cloud platform like Azure Cloud, the identity provider will be, Azure Active Directory. Microsoft Entra ID will provide the identity. So make sure you implement a guarded identity from authorized identity provider for the agent. Agent JWT, that's OAuth 2, standard JWT claims plus agent specific metadata like agent type, task ID for task downstream authorization. And then we have agent token manager, manage JWT lifecycle, handling automatic token renewal and revocation via a shared list. So these are ways that you can design authentication to your agentic design pattern by implementing identity, by scoping credential capability, by implementing, credential to perform particular task, by using identity provider, by implementing OAuth 2 via the agent JWT and agent token manager to manage how the agent uses token. So identity creates accountability. So by designing for authentication and identity, you are making sure that each agent are held accountable for what they do in your system. Assign task credential. So task credential enforces least privilege at execution time, not just at deployment. Implement OAuth 2. This is a JWT capability, which gives short-lived revocable access to protected application interfaces. And then in section 8.2, we have a pattern, design pattern for how to secure inter-agent multiplication using TLS 1.3 or mTLS. So without TLS and message integrity, communication is vulnerable. So inter-agent communication security is what we discuss in section 8.2, where we have a mutual TLS, both sides. Implement mutual TLS at both sides to authenticate each other. So agents should have mutual TLS, which is mTLS, to communicate. So this prevents rogue agents, man in the middle attacks, unauthorized, sources, and certificate supporting. So only agent with valid enterprise issued certificate can communicate. If the agent does not have enterprise certificate from the OAuth 2 or from Microsoft Entra certificate, it will not be able to perform any tasks in the system. So make sure you assign certificate. Then certificate notation must be automated. Expire certification can break workflow. So do not just implement use certificate. Make sure certificate rotation is automated. If you design it to expire after 1 year, this automate the renewal and regeneration of the certificate so that the workflow will not break. Message signing, which is mTLS, protect the connection. It protects the connection between agents. So message signing protects the message itself. Message signing make it impossible to change or approve a flagged message during transit. So it is very, very important. Message signing design, a multi-agent system design, must be put into consideration as you also design your multi-agent system. So this is all we have in section 8.2, inter-agent communication protection. So as we have heard, agent mTLS config is the function for implementing mutual TLS for agent communication, that is agent to agent communication or protection, certificate rotation to avoid to avoid, breaking the workflow. Make sure you automate certificate generation into the system. The certificate expiry monitor. Make sure you monitor when certificates for a particular agent would expire. Make sure alerts are triggered and make sure the certificates are replaced before they expire. Signed agent message. Ensure integrity, prevent spoofing, agent spoofing. Then we have agent message signer. Signs and verify agent messages. And then we have replay prevention, which rejects stale or duplicate messages. This allows agent to reject stale or duplicate messages, which also prevents message or database poisoning. And then in section 8.3, we have data privacy and encryption. So privacy is very, very important. PII information must be redacted, contract terms must be protected, and financial figures must be hidden to the agent. So enterprise handle PII, contract terms, financial figures. So all these are what you should protect, redact, and encrypt in the system. So at rest and in transit, data must be secured. Feed level information must be secured. Storage must be secured. Transport information must be secured. Log traces and inter-agent communication should not leak PII. Very important. Very, very important. Make sure you redact PII. So tier 1, we have field. So sensitive field are encrypted before storage. Make sure you encrypt identity, phone numbers, account numbers, etc., bank accounts, account details, amounts in the account. All this should be encrypted. Keys are agent specific to prevent cross-agent decryption. So you can use key to encrypt all this information. Tier 2, that is feed level information. Tier 2, disk, that is the storage itself. So full disk encryption on all storage volume managed through the cloud provider key management service must be implemented. Then tier 3, that is transport layer information. So implement TLS 1.3 or 1.2 for all data in transit and mTLS for agent-to-agent communication, as we have said. And then in tier 4, we have encryption management. So this manages context-aware encryption where the key is derived from field, purpose, and context. So manage all the encryption as well. Then PII reductor. Redact PII from output logs before leaving the agent boundary using pattern matching and name entity recognition detection. So it's very, very important that you implement this as well. Then minimize data minimization and anonymization. Anonymization for PII, minimization for API usage, database usage, and so on. So deductor is a last chance defense. Agents should not collect PII they do not need. It is very, very important. Implement minimization to role-based access control, which is role level security, and attribute-based access control for column level of security. Agent system access control. Extend role-based model to autonomous non-human agents. So this is full role-based access control. So this access control is very, very important. Security is not an afterthought, guys. It is what you should design from beginning. In fact, security should be the first thing that you will implement before you start designing your agent. So access control must be precise. Okay, it must be role-based and attribute-based. RBAC and ABAC. Okay, access control must be enforced at all time before every sensitive action is implemented. You can see how important it is. Permission, explicit permission revealed as part of security governance. Do not just give permission to all API, to all database, to all information. Make sure permissions are reviewed and limited by security governance. Agent role, a named governed set of permission for an agent type. Make sure you have a name for each agent. Make sure you have governed policy-based permission for each agent type. Okay. Financial threshold. Roles defined mass transaction value require human approval above limits. These are kind of functions that you can implement for financial threshold. So define roles like mass transaction value. That is, if you are designing, a kind of transaction agent, for instance, and you should define a limit. For example, maybe the agent should not implement any value that is above $500,000. It should require human in the loop approval for that kind of amount. So that's how you can set financial threshold or for an agent. Then we have agent rules. So this covers description, data classification, and allowed working hours. So agent rules define covers description of the agent. So this is where you define the description of the agent, what the agent can do and what he cannot do. Okay. Data classification. You classify the data that the agent can use and collect, and the one he cannot use and the one he cannot collect. And then you also define the working hours, allow working hours of the agent. Agent that is meant to work at 1 p.m. or maybe 8 a.m. to 5 p.m. should not be working overnight. Okay, it can, when you are not supposed to be having a vendor overnight, vendor accessing your platform overnight, anything can happen from there. So define agent rules, just like you have daytime security and nighttime security. Have daytime security and nighttime security of agents. So a worker that is meant to work from 8 a.m. to 5 p.m. cannot just resume 8 p.m. and work from 8 p.m. to 5 a.m. No, that is fishy. And, it's meant to be investigated. So define agent working hours as well, just as you have human working hours. So agents access control enforcer. So runtime enforcement called before every sensitive operation. So make sure you implement runtime enforcer control. So collect access control also, or enforce access control at runtime. Audit trail logging. The enforcer log every access granted or denied as primary evidence. So implement audit trail and collect audit trail logging. Very, very important for governance, policy, and security control. That is all we have under access control, which is section 8.4 of the book. And then in section 8.5, we have audit trails and compliance. So audit trails demonstrate accountability to regulatory bodies. Okay, so just as you have, human resources are defending workers and protecting them from, profanity and corrupt managers and all that. You also have audit trail that enable that agents are accountable for their activities, so that agents will not send wrong information to another agent. So the audit trail and compliance demonstrate accountability to regulate the agentic systems. They act as regulatory body for the agent. So you have immutability. Audit record must include who, what, why, under whose authority, based on what data, and with what outcome. So the audit trail is append only and cryptographically change, making tampering detectable. So when anything is tampered with, you can easily detect which agent does that, or which agent broke the rule, or which agent misbehaved. If somebody misbehaves in an organization, for example, if a man misbehaves towards a woman, the woman can report to the HR and they take it up with legal authority, and from there the issue will be escalated. So that human resources serve as, a protection layer for workers against toxic authorities, toxic managers, and all that. So that can also be implemented in agentic system. So design for audit trail so that you can take record and make each agent accountable for what they access, what they use, what they perform. and you can answer the question who, what, why, under whose authority, based on what data and with what outcome something is being or done. So we have the design pattern for audit trail and compliance. First is audit record. So immutable record of agent ID, event type, decision basis, and the outcome must be collected. Crypto chaining. Hash of the previous record create a tamper evidence sequence. Make sure, or in supply chain, for instance, where this are being implemented, make sure hash of every record must be hashed so that you can use the hash, use the hashing to trace a particular action to a particular agent, even though everything in chaining, crypto chaining, are real time. You can implement hash to trace every activity to a particular agent. Retention classes maps event types to retention period, e.g. can implement SOS 7 years, EPA 6 years, and so on and so forth. So this define how long should you keep audit record in the system. Then we have immutable audits. These are append only record, real-time event to auth part, long-term to code part, etc. Integrity check. These are mechanisms used during audit to prove record were not tampered with. Okay, so make sure you check integrity of each agent to make sure or record in the system they do not tamper with what they are not supposed to tamper with. Then query by resource. Support investigation by answering queries like resource activity by date. So make sure you query resources, make sure you query and investigate what is happening in the system by using dates and an agent ID to retrieve information. And that is what we have in section 8.5. So in section 8.6, we have threat modeling for intelligence system. So threat modeling for multi-agent system. Traditional frameworks like STRIDE miss agent-specific risk like prompt injection and swarm exploitation. So because agents are just like collection of enterprise workers. So what you implement for a single application like STRIDE cannot be implemented. You have to go beyond that to be able to implement a threat modeling to detect and protect against external threats, internal threats, and internal multi-agent misbehavior. So agent introduce new risk. Of course, use Maestro aligned threat modeling system. So Maestro, what are they? So these are like a prompt injection defense, which require input control and output validation. So you must control what is coming into the system and you must validate what is going outside the system. Very, very important. And the design you can use a Maestro framework, which is 7-layer cloud security alliance architecture designed for agentic system. We have in Azure, we have Azure WAF, Azure Web Application Firewall, and Microsoft Defender. We have Defender for cloud, and so on and so forth. What you can implement front door, Azure front door, which is layer 7, which over layer 7 security as well. Then we have prompt injection. Input causes agent to override system instruction and take authorization action. So defend against prompt injection. Memory poisoning. Defend against memory poisoning by making sure that corrupted data in shared vector store do not compromise future agent decision. Okay, so also design swarm exploitation. Do not allow agent to exploit each other. So exploiting coordination mechanism to amplify a single agent compromise. Agents should not exploit other agents. It is very, very important that you design for that. Supply chain, malicious code via compromised dependencies, container and model weight. So also design for that by implementing hashing. All chain must be hashed. Then injection defense, runtime sanitation that strips injection pattern and define boundary rules. So make sure boundary rules are defined. So also the way we implement boundary with people, you set boundary in office. People set boundary. You have you have the boundary that you can cross with people, and then you have boundary that you can never cross. So make sure we should make sure we define boundary rules for agents. Okay, set boundaries for them. Then in section 7, we have vulnerability management. So this covers software scanning, AI-specific testing, and red teaming to manage a vulnerability. So traditional software and AI-specific both must be tracked, assessed, and remediated. So to also track traditional software against vulnerability, AI-specific must be tracked against vulnerability. Your LLM must be tracked against vulnerability. Make sure your LLMs are not vulnerable, so all the agents will not be vulnerable at the same time. So all this traditional software application and AI-specific software must be tracked and governed. So vulnerability scanning, AI red teaming must run alongside normal CVE scanning. So all this must run at the same time. So this is how you can design for vulnerability management. You can, implement for traditional software, CVE in Python packages, container images, Kubernetes config use as SBOM scanning. Make sure you scan them for vulnerability. Scan your Python codes, scan your Python packages, scan your container images, scan your Kubernetes config and everything using SBOM scanning. Then for AI specific risk, make sure you implement susceptibility to prompt injection, implement jailbreaking and information disclosure. Okay, so to prevent against AI specific vulnerability. Then agent manager. So implement lifecycle here for agent manager vulnerability. Set dependency scans on every build and AI specific red team assessments. AI red team. How do you prevent AI red team against vulnerability? So here you can evaluate attack success rates for prompt injection and jailbreaking by using PII, RIT, or GRAC implementation. Self-ready ranking. So you can rank via CVSS or AI success rate paired with business impact at critical by setting it to critical or low, from critical to low. And then we have remediation. So fixed dates, e.g. 24 hours for critical, 7 days for high in the vulnerability register. So set remediation task for remediation. To implement remediation task, set fixed date for operation. 24 hours for critical or 7 days for high, etc. in your design. And then we have governance framework, which is what we discussed in section 8.8. So governance and policy. So security equals protection and governance equals accountability. So by implementing security, you are making sure that the multi-agent system are secure and protected. And by implementing governance, you are making sure that every agent in your system are accountable for what they do. So here we have a character, no approved governance. So we have governance charter. So no approved governance charter before deployment. Then we have governance charter becomes real only when enforced at runtime. And then the correct workflow should be permission, ERP read, not the vendor analyst, or define ERP read in permission, etc. Security, compliance, and governance architecture guide to enterprise mass. So this is what we, everything we talked about in 8.8 about governance. So let's look at what we have in our side or our slide here. Accountability ensures that organization knows what agents are deployed, their authority, and how behavior is monitored. So governance framework enable agents to be accountable It also enables the developers to be accountable for what they deployed into the enterprise system. So there should be governance team in enterprise that will govern agent workflow, okay? Monitor which agent is deployed, what the agent is assigned to do, knows the identity of the agent, know the authority of the agent within the system, know the API that they can access and the one that they cannot access, know the behavior and make sure the behavior of the agent in the system are monitored. So this is the work of governance team. They must make sure that policy of the organization are enforced into the multi-agent system. So this is how you can design for governance a multi-agent system design. So agent governance charter. So this is complete governance spec for an agent type, approved as a contract with legal risk functions. Then we have authority definition. These detail the capability scope, financial authority limits, and decision requiring human approval. So authority definition set boundary for the agent. Okay, agents have limits. They have their capability scope. They have what they can do, and they have the threshold of what they can never go beyond. Then we have governance policy engine. These are operational charter implementation that intercept agent decision and enforce limits. So governance policy engine enforces limits to the capability of the agent. It limits what the agent can do. It sets threshold for the agent that the agent should not go beyond this task. So if it goes beyond that task, it's violating the policy of the system. So maybe those kind of tasks should be routed to human approval before they can continue. So 40% AI break risk. Gartner projects significant data breaches by 2027. This is, the what has been forecasted in agentic governance. So you can see what they forecasted, that by 2027, there will be 40% data leakage in enterprise as a result of, not implementing governance into the system. So stemming from generative AI misuse. So do not misuse generative AI. Set predefined governance, set authority definition, set boundaries, implement governance engine, implement agents governance charter into the system from beginning so that you can take agent accountable for what they do and also take developers accountable for what they develop. And this also will enable that developers follow predefined standard before they design agent in the enterprise. 4.8 million average incident cost. You look at what has been forecasted. Incident cost. Okay, 73% of enterprise reports AI security incident averaging hits a month per incident. So look at what incident management is costing enterprise as a result of not implementing governance. Look at escalation. So we can prevent against this by implementing governance into the system from beginning to ensure accountability. And then we have the architecture for security and governance. As I have told you, the book is all about architecture design, how to design agents by implementing security and governance is what we have in chapter 8, and we have the full architecture of the workflow of chapter 8 here: identity access control, auditability, runtime policy, enforcement. And then we have the first layer, which is where you implement identity. Make sure you have identity provider like Microsoft Entra ID, Active Directory. Make sure you have agent service account, which is agent identity. Make sure you have task credential or old author 2 via JWT. And then we have the control plane. This is where you implement policy engine, least privilege, role-based access control, and attribute-based access control into your system. We have your RBAC, we have your RBAC and ABAC, you have the policy engine, you have the least privilege, all implemented and linked to the agent. So this is your multi-agent layer. And even inside the multi-agent layer, you are implementing message transport level security plus message signing into your system, also ensuring that agent to agent communication is secure, in-depth. So you have your multi-agent runtime here, where you have all sorts of agents here: planner agent, executor agent, validator agent, monitor agent, all connected using your orchestrator layer. And then, so here, access control or least privilege policy engine, and at the other side, you are also protecting using your firewall. You can see the wall of protection. You are protecting against prompt ejection from external, external vampires. Let me call them vampires. You are also defending against threat detection. You are defending against, you are also putting email review to also review whatever is happening within the agent communication. And then we have the protection layer. So the protection layer is where you protect your PII, your database, audits, and governance. So we have encryption of database using KMS, which is platform generated keys like Azure KMS. We have PII redaction, so redact personally identifiable information, okay, before they go out there. And then we have immutable audit trail, so collect every login activity of the security and governance, okay, in the system. And the governance charter, implement governance charter overall layer to protect and make sure agents are accountable for their operations. And then enforcement actions. So here we have a, so if each of these protection layer are violated, what action should happen? So if KMS encryption is violated, the activity should be blocked. Block the activity or block the agent entirely. If PII is not redacted, escalation should be enforced. If immutable audit trail are not protected, then there should be human review. Every activity should be reviewed, and then a governance charter enforcement action allowed. So this one should be set to allow. And then security outcome. So what will you have in your system when you implement all these security layers: identity control plane, protection layer, and enforcement action? What you'll be having, a system you'll be having is controlled authority system, secured communication system, tamper evidence or audits. So you have whatever happened inside the agent system, you have tamper evidence, and then you have accountable decisions. So everybody, all the agents will be accountable for their decisions, activity, and operations. So what is security message that we want to take away from this chapter 8? So I have summarized, as usual, the message into 3 information. The first information is every agent needs identity. Make sure you give a service account to assign a service account to every agent so that you can identify them and what they do and their misbehaviors. Governance must be enforced at runtime, not an afterthought. So implement governance at runtime to take agent accountable for what they did, and implement autonomy. Autonomy also require controls. So autonomy does not mean 100% freedom. No, make sure you implement controlled autonomy into your system. So, all right, everyone, this is all we have in chapter 8, security and governance in depth and how to implement them. So what you are building by implementing this is actually harnessing or harness engineering, which is the popular term that is training in multi-agent system designer. So when you design this, you are automatically performing harness engineering around your agent. So thank you, everyone. Please like and subscribe to this channel so you can receive more information from us. Also buy the book and leave a review on Amazon or on my website, which Remas AI Solutions .tech, which I will link I will leave the link in the information below. Thank you.